So this load is 2 kilonewton and this is 4 kilonewton and this is 2 kilonewton. This is a simply supported beam. We'll be having the reactions at both the ends. So this is the beam diagram. I have to calculate the shear force at different points A, B, C, D, E and the bending moment at the same points. So this is the reaction RA and this is the reaction RP. Now we have to calculate what is the reaction at A and what is the reaction at B. To find the reaction, you take the moments about any of the points A or B. I am taking the moments about the point A. Taking moments about A. So I am taking the moment about the point A. You can write like this: sum of clockwise movements is equal to sum of anti-clockwise movements. So if I am taking the moment about A, what are the forces which will cause the clockwise movement? So this is the point A. Due to the 2 kilonewton force, this will be having a clockwise movement and this will be having a clockwise and this will be also having a clockwise movement. Due to this reaction force, we will be having an anti-clockwise movement. So the clockwise movements are 2 kilonewton force into 1 plus 4 kilonewton. I am taking this force, and what is the distance from point D to A? Or you write the formula first and then you proceed. First, the 2 kilonewton force into the distance AC. Then I am having the 4 kilonewton force into the distance AD. Then I am having the 2 kilonewton force into the distance AE. So this all are the clockwise moments. This will be equal to the anti-clockwise moments. The anti-clockwise moment about the point A. So this will be giving you anti-clockwise moment, the reaction force at B. So RB into the distance between the point A and B, that is AB. Two into the distance AC is 1 meter plus 4 into AD. AD is 2 meter plus 2 into AE. AE is 3 meter. This is equal to RB into AB. Your AB is 4 meter. So if you solve this, you will be getting 4 RB is equal to 2 plus 8 plus 6, that is equal to 16, or I can say RB is equal to 4 kilonewton. So we have found that RB is equal to 4 kilonewton. Now I shall calculate what is the value of the reaction at point A. So now we resolve the forces in the vertical direction, that is in the y direction. You resolve the forces in y direction. The forces acting on the downward direction will be equal to the forces acting in the upward direction. So in the upward direction you are having two forces, RA plus RB. This is equal to the vertical downward forces, that is 2 plus 4 plus 2. We know what is the reaction at point B, so I can write like this: RA is equal to 8 minus RB, that is 8 minus 4. So your reaction at point A is 4 kilonewton. So I have the values of the reaction at A and B. This is RA is 4 kilonewton, and at B the reaction is also 4 kilonewton. So this is your beam diagram. Now I have to calculate the shear force at the different points and draw the shear force diagram. So to draw the shear force diagram, you put a horizontal line. This is your shear force diagram. So at the extreme right, I have to calculate the shear force. For this, you take any section between the point E and B. Any section between the point E and B, and you consider this as X. So the shear force will be given by plus 4 kilonewton, because if you consider this section like this, the force is acting in the upward direction and to the right of the section. So this will be having a positive value. If it is like this, you will be having a negative value, but I am having this case. To the right of the section, I am having the force in the upward direction, so it is a positive shear force. So to the right of the section, I am having only one force, that is 4 kilonewton. So you can draw a line like this. So this is 4 kilonewton and it is in the positive side. Between E and B there is no loading, so I can say the shear force remains constant. So you put a straight horizontal line like this. Now at point E, you are having a downward force of 2 kilonewton. Now you consider any section between E and D. Any section between E and D. Any section between E and D at a distance x. So we'll be having like this: D, E, and B. At B, I'm having a 4 kilonewton force, and at E, I'm having a 2 kilonewton force. This is your section. So to the right of this section, you are having two forces, one in the downward direction and another in the upward direction. So this is upward, I can take this as a positive, and this is downward, I can take it as negative. So 4 minus 2, this will be giving you 2 kilonewton. So the shear force between E and D remains constant at a value of 2 kilonewton. So between E and D, I am having a shear force equal to 2 kilonewton. Okay. So initially from B to E, I am having a shear force as a constant value of 4 kilonewton. At point T, I am having a downward force of 2 kilonewton. So the shear force decreases like this. And from E to D, the shear force remains constant at 2 kilonewton, positive value. So I am drawing above this red color horizontal line. And if you draw below this horizontal line, it will be taken as a negative one. Now you consider a section between C and D. So if you consider a section between C and D, you'll be having like this: C, D, E, and here I am having B. So here I am having a upward force, here downward force, at D a downward force. So if you consider a section like this, to the right of this section, you note down what are the shear force acting and in which direction. So this 4 kilonewton force is acting in the downward direction and to the right of the section XX. So it has to be taken as a negative. And similarly, this 2 kilonewton is acting in the downward direction to the right of the section XX. This is taken as negative. And this is acting at point B in the upward direction and to the right of the section XX. This is taken as a positive one. So you add all these forces. So the shear force between C and D can be written as minus 4 minus 2 plus 4. This will be giving you minus 2 kilonewton. So the shear force between the point C and D is equal to minus 2 kilonewton. So these are the points representing the C and D. So at between the point C and D, your force is minus 2 kilonewton. So I'm drawing like this. I'm drawing below the red color horizontal line because this represents a negative value. See, at point D, you are having a downward force 4 kilonewton. That's why the shear force changes from 2 kilonewton to minus 2 kilonewton at the point D. Now I have to find the shear force between the point A and C. So you consider a section between A and C. If you consider a section between A and C, you can take any direction to the left of the section or to the right of the section, which is convenient to you. I'm taking the section to the left of this x. So if you are having the beam like this, I'm having this force reaction at point A that is equal to 4 kilonewton and this point C, and this is your section. See, to the left of the section, if I'm having a downward force, it will be taken as a positive one. And if to the left of the section, if I'm having an upward force, that will be taken as a negative one. This is left and this is right. So for the reaction at the point A, you see the force is acting in the upward direction. If it is acting in the upward direction, you will be having a negative sign. So the shear force between the point A and C is given by minus 4 kilonewton. So between the point A and C, the reaction force is minus 4 kilonewton. So here I am having 4 kilonewton, that is in the negative direction. Now we join this. So this is the shear force diagram of the given simply supported beam. So this is the shear force diagram. Similarly, you have to calculate the bending moment at different points and you have to draw the bending moment diagram. So now we shall see the bending moment diagram. So you draw a horizontal line like this. From point A and B, draw vertical projections to this horizontal line. Now you have to calculate the bending moment at the different points A, B, C, D, and E. The bending moment at the point B is 0. We know that the bending moment formula is force into perpendicular distance. So at point B, the bending moment at point B is equal to 0. Similarly, the bending moment at the point A is equal to 0. Always for a simply supported beam, at the support at the point A and B, you will be having the moments as 0. Here I am having the moment as 0, and here also I am having the moment 0. Now at point E, what is the moment? At point E, so you have to consider the distance while calculating the moments. So you put the distance like this. So to find the moment at point E, you have to take this force 4 kilonewton, that is the reaction at P. So RB into 1 meter. RB into 1 meter. You can take either the left side or the right of the point E. So I am considering the points to the right of the E. So RB is 4 kilonewton into the 1 meter is the distance between the point B and D. So this will be giving you 4 kilonewton meter. Now we have to check whether it is a positive or negative value. If I am considering the point E, and if the force is acting in this direction, the beam will bend like this. So this shape, curvature, can be taken as a positive bending moment, and if the beam bends like this can be taken as a negative moment. I am having this case. So you can put plus 4 kilonewton meter. So at point E, I am having the bending moment of 4 kilonewton meter. If the shear force between the point E and B remains constant, then the bending moment will be varying in a linear way. So you have to connect these 2 points using a straight line, not using any curves. So this is 4 kilonewton meter. Now I have to calculate the bending moment at point D. You can write like this: RB into the distance PD. So this will be having a positive, and then the force at point E into the distance DE. This force is acting in the downward direction, so you can put a negative sign for this. So RB is 4 and the distance BD is 2, and the force at E is 2 and the distance DE is 1. If you solve this, you will be getting 6 kilonewton meter. So this is the bending moment at point D. So at point D, I am having a bending moment of 6 kilonewton meter in the positive side. You have to connect this point and this point using a straight line, because between the point D and E, you are having no loads. Also, the shear force remains constant between the point D and D. If you are having a constant shear force between 2 points, then in the bending moment diagram, you will be having a linear variation and not a parabolic or cubic variation. Now you have to calculate the bending moment at point C. So the bending moment at point C is given by, you can take any section to the right or to the left of the point C. See, to the right of the point C, I am having 3 forces, 1, 2, 3. So I have to take these 3 forces and multiply by the respective distances. But to the left of the point C, there is only 1 force. So it will be easy if I take the forces acting to the left of the point C. So moment at about point C is given by this force RA into AC. So RA into AC. See, you are having like this. This is your reaction A. This is your point A, and this is your point C. So this force, reaction force, is acting. Your beam may bend like this. If your beam bends in a shape like this, then it will be taken as a positive one. So RA is 4 and AC is 1. That will be giving you 4 kilonewton meter. So the moment about point C is 4 kilonewton meter. Now you have to connect the points between these 2 points. So this is 4 kilonewton meter. And what is the bending moment at point A? It is 0. If you want, you can check.